Hello, in this video we're going over some GCSE Physics practice questions on motion. Question 1, the graph represents the movement of body. Here's a speed time graph showing a constant acceleration here with a constant gradient. How far has the body moved after 2 seconds? So this distance is the area under the speed time graph. So what that means is this area here is the area of a triangle, so it's a half times the base times height. So it's a half times the base times the height. Okay, but we're talking about 2 seconds, so it's only this area. Okay, if for 2 seconds. The bigger triangle area would be if it's moving for 5 seconds, the total distance. But if we're just considering to 2 seconds, then we do times 2, which is the base, times 4, which is the speed that it's reached after that 2 seconds. And that gives us an answer of 4 meters. So that would be our circular answer. If we did the total time, how far has it traveled in the whole 5 seconds, we'd do a half times 5 times 10, which would give us 25 meters. How far has the body moved after 5 seconds? There we go, 25 meters. Question 2. The circuit of a motor racing track is 3 kilometers in length. In a race, a car goes 25 times around the circuit in 30 minutes. What is the average speed of the car? So average speed is the total distance divided by the total time. 25 times 3, 25 lots of the circuit, which is 3 kilometers. So its total distance is 75 meters divided by the total time, 0.5, gives 150 kilometers per hour. And in this question, you don't have to convert it to meters per second or anything like that. You just do a straightforward because the answers are given in the options are kilometers per hour. So this one's going to be C. A snail moves along a ruler. It takes 20 seconds to move from Q to R, from there to there. Okay, so it's going from 2 centimeters to 12. So it's gone 10 centimeters. What's its average speed? It's the total distance divided by the time. 12 minus 2 is 10, divided by 20 gives the answer. In this case, that would be 0.5 centimeters per second, but it's just the question is just checking that you know about which method to use to work it out. Question 4. 2 distance time graphs and 2 speed time graphs are shown. Which graph represents an object that's at rest? Well, let's go through them one by one. Graph A shows distance, time, and distance is increasing with time uniformly, so that shows a uniform speed, the thing's moving. C, speed's time, the thing's moving and it's increasing in speed over time, constant acceleration, so that one's definitely not at rest. And D, constant speed with time, again, it's moving forwards at a particular speed that's positive non-zero speed, so that's definitely not at rest either. The only one at rest is B. The distance is not increasing with time. The object is just at rest. Question 5. An object moves initially with constant speed and then with constant acceleration. Which graph shows this motion? That will be B, constant speed and then a uniform acceleration or constant acceleration. Graph A is not correct. This is showing an increasing speed and then a constant speed. Graph C is showing a constant acceleration and then a non-uniform increasing rate of acceleration. D has got a uniform acceleration and then a decreasing non-uniform acceleration. Question 6. A car travels at various speeds during a short journey. The table shows the distances travelled and the time taken during each of 4 stages P, Q, R and S. During which 2 stages is the car travelling at the same speed? So you just got to calculate the speeds for each one using V equals D over T, speed equals distance over time. With P, we get 1.8 over 2, 0.9, Q, 3.6 over 2, 1.8, R, 2.7 over 4, 0.68, S, 2.7 over 3, 0.9. So, where are these travelling the same speed? Is P and S. In the following 4 questions, air resistance can be ignored. 7. A cyclist crosses the start line at 8 meters per second and accelerates at 1.5 meters per second squared for 30 meters. What's his speed after 30 meters? Use v squared equals u squared plus 2as. 8 squared plus 2 times 1.5 times 30, 154 meters. Therefore, the average speed, or the speed rather, the final speed rather, is 12.4 meters per second. Question 8. A helicopter pilot hovers over a field and drops supplies to a rescue team below. If the supplies fall for 4.5 seconds, what is the height of the helicopter above the field? Use s equals ut plus a half at squared equals 0 plus half times 9.81 times 4.5 squared equals 99.3 meters. 9. An electric vehicle accelerates uniformly from rest at a set of traffic lights to a speed of 50 km per hour after travelling a distance of 120 meters. So we can use v equals d over t, 50 kilometers divided by 1 hour is 50 times 1,000, so that's 50 times 1,000 meters divided by 60 times 60 seconds. There's 60 seconds in a minute, 60 minutes in an hour, so you do 60 times 60 for the number of seconds. This gives us 13.9 meters per second. What is the acceleration of the vehicle as it moves from the traffic lights? V squared equals u squared plus 2as. Therefore, 13.9 seconds equals 0 squared plus 2a times 120. Therefore, a equals 0.81 meters per second squared. So if you want to give your answer in meters per second squared, then and use these equations, you need to be consistently with your units. So not use 50 kilometers per hour, but use 13.9 meters per second. So you have to do that conversion first. How long did it take the vehicle to reach a speed of 50 kilometers per hour? V equals u plus at, 13.9 equals 0 plus 0.805 t, so time is 17.3 seconds.